Up next, we have an incredible project that we'll be presenting. We've got Arjun Bhuptani joining us from Connext. He's a co-founder, and he'll be speaking about Connext's instant cross-chain communication for Ethereum L2s. So this is a project we are really proud to be working with and are excited to hear more about what he has to say. So I've just added you to the stage, Arjun. Hey,
hello.
how's it going?
Hey, can you guys see me and hear me?
Perfectly.
Awesome. Yeah, thank you so much, Aiden.
Thank you. It's such a pleasure to have you here. I'm going to turn off my camera and mic, and please just take it away.
Okay, awesome. Let's see, I have some slides. Let me get them up and running. Cool. Well, thank you for having me. I appreciate you guys having me here. I'm Arjun. I'm one of the founders of Connext. Today, I'm going to be talking about a new network that we've just put onto testnet called Vector. Vector enables instant cross-chain communication between Ethereum layer 2 chains and also different layer 1s. Basically, it can serve anything that's Turing complete. So it's a pretty exciting development, especially as we get into this new phase of having many, many, many more chains. Getting started. So I think the context for a lot of this is that no matter how things shake out, regardless of whether you're a proponent of like a rollup centric Ethereum future or ETH2 with a bunch of different shards, or like a plurality of chains where you have a bunch of different layer 1 ecosystems, or Polkadot or Cosmos. The bottom line is, I think one thing, what we're kind of starting to realize from a research perspective is that there's like physical limitations to having a single global consensus system that everybody runs their state on. And the only way to get out of this is to have a multi-chain world. And by that, I don't necessarily mean that there are a bunch of different chains with different validator sets, but at the very least, there are a bunch of different chain-like environments that have their own isolated state that need to then communicate that state with each other. And this brings up this new core problem, which is how do you actually communicate state between different chains? How do you actually take value, liquidity that exists on a single chain and then move it to a different ecosystem? You know, in the Ethereum space, this is actually increasingly present as we move towards like a more layer 2 enabled paradigm. What happens if you have your balance in MetaMask on top of Arbitrum and you need to call the Uniswap contract running on top of Optimism? As a user, this is a pretty awful user experience, not only because you now need to understand the difference between Arbitrum and Optimism, which is something that pretty much no user ever wants to do, but also because for the Ethereum layer 2 specifically, there's also this additional headache of timeouts to get into and out of these systems. So getting out of Arbitrum, for instance, will take at least a few hours. Getting out of Optimism could take at least a few hours. I think in some cases it's actually up to a week. In ZK rollups tend to do a little bit better, but it's still nowhere near what you would want to see, which is like a single block, ideally, to get into and out of these systems, and then even ideally even lower to be able to communicate across them. So in the example that we mentioned above, if you want to get from your funds from Arbitrum to call a contract on Optimism, you need to exit Arbitrum, which can take like a few hours at least, if not up to a week. Then you need to subsequently pay money and take time to get into Optimism, rather than being able to go directly. Ideally, what we want here is actually just a shared routing layer that allows you to move value between these chains, right? We want a consistent standard that everybody enforces that says, okay, if I have value on so-and-so chain, I can get it to some other chain simply by promising it to somebody, and swapping for value on a second chain. This, as it turns out, is easier said than done. But we have the good thing is we can draw upon like existing networks like the internet itself to figure out how should this be built, how should this be structured. So now taking a little bit of a step back, this is kind of a little bit of a background of the problem statement and of the direction they're going and why this issue exists. So let's start now looking at Connext specifically. And also state channel networks more broadly, and then like Ethereum layer 2 chains as well as other chains. Now everybody, generally most people have a rough understanding of how like a blockchain works. Any chain is effectively a consensus system made up of a bunch of different validators. Those validators check to make sure that everyone that the state that's being put into a subsequent block is correct and is valid and isn't actually destroying anybody's value, and then everybody comes to consensus on this. Generally, Ethereum scalability solutions and most other scalability solutions out there have a similar pattern where they basically like scale up, like horizontally. And there's the pattern here is very, very similar to like how you scale up servers in a server stack. You basically just add more servers, and you add like the ability to communicate between them. And that's kind of what like Ethereum scalability solutions do. It's like in many different ways, they allow you to create more chain environments where you have their own isolated consensus systems, and that can happen either via side chains, like things like XDAI, where you're basically just running an entirely separate chain with a separate validator set, or plasma chains like Matic, where you have a separate chain, separate validator set, but then there's basically an operator that is like held cryptoeconomically held liable for funds getting into and out of the plasma chain. Or you have things like rollups, which are a little bit more akin to like containerization / virtualization environments, where like you're not actually achieving consensus between like a bunch of different validators, but you're effectively emulating that consensus exists, and instead you're falling back to the validator set of Ethereum itself. And in all of these cases, like you can kind of see that it's really kind of, to the user, it looks like the same thing, right? It's basically Ethereum faster. And in all of these cases, the way that you're building these things is you're like either forking Geth or you're forking Ganache. So really, like from a user perspective, all of these things are kind of the same thing, right? Like it's a version of using Ethereum, but it's faster and cheaper. And the added headaches are basically like nuances around security that many users will not understand. It's really up to us to be the ones who kind of say, okay, well, this is secure, this isn't secure. Channels are a little bit different, and Connext specifically is a little bit different. Unlike many of the projects in this space, Connext is not actually a chain. It's not a chain emulation environment. We don't run anything related to Geth or Ganache. We don't run anything related to Bitcoin, like the actual like Bitcoin core stack. And that's a pretty big break from like what most of the projects in the space do, because in general, almost everything is like originally forked for Bitcoin. I think that's actually really important, because that's a part of why channels are so hard to build. That's a part of why like it's taken a long time for people to get to a position where like you have like fully working stateful state channels on Ethereum that work in a generalized way. But more importantly, it also helps explain why this type of technology is actually might be suited to solving this problem that other chains may not necessarily be able to do as easily. And that's the core reason for this, is that instead of being a chain, Connext is a peer-to-peer network that allows you to do point-to-point communication. Basically, it's a network of unbreakable commitments. I develop a relationship with another person. That relationship is a channel, a state channel. In that relationship, I have funds locked up, and I'm making, when I make state transitions in that relationship, what I'm basically doing is promising to that person, or committing to that person, that I'm going to pay them at some point in the future. And the great thing about these commitments, and this is kind of like the core property of why state channels are their own isolated, like trustless mechanism, is that those commitments are totally unbreakable, right? Like provided you make some assumptions about the chain, like the chain itself can't be censored and the chain is fault tolerant, et cetera, et cetera, et cetera. Provided you make some of those baseline assumptions about the chain, any commitment that you generate in a state channel will always be able to be resolved. And that's actually pretty powerful, because it's not just this relationship that you have with one other person, but you can link many of these relationships with each other. So for instance, here we have, like from left to right, like Alice, Bob, Charlie, David. Alice and Bob can have a state channel between them, which is a bilateral relationship, and then Bob and Charlie can have a state channel between them, which is another bilateral relationship, and Charlie and David can have another state channel. And what's really interesting about this is that because you have the ability to do any arbitrary type of conditional transfer in each of these channels, you can actually make it so that Alice can transfer to Bob conditionally upon Bob transferring to Charlie, conditionally upon Charlie transferring to David. So you have this like you can have like hopped value transfer that goes over multiple different intermediaries. And this looks really, really similar to the internet, right? On the internet, you have a bunch of service providers that make up kind of like the backbone of the internet, and those are routers. Routers forward data packets. And when you are connecting to another person over the internet using TCP/IP, what you're actually doing is like you're connecting to some local router, which is connecting to another router, and so on and so forth. And you're basically pathfinding through this network to be able to get to your required destination. And what's interesting is that on the internet, you have these routers may be running on like totally heterogeneous networks. So you actually might be able, this is part of the reason why like you could do internet-based payments, and you have things like Twilio, which allow you to connect to phone networks, and like other kinds of different network ecosystems that are not actually the same, and they don't necessarily all need to be running TCP/IP. And instead, you have this like broader network of things that just has this shared communication layer that allows you to interoperate between these different types of ecosystems. And the same kind of core principle exists within channels. You can run the same channels, the exact same system on any Turing complete chain. This is the exact same system that we're running today, and that's really, really powerful. So rather than just having this earlier system where we have just like Alice and Bob and Charlie and David all on Ethereum with each other, or on whatever, Polkadot, Solana, anything. Instead, you can actually have it so that Alice and Bob's relationship is on Ethereum, Bob and Charlie are on Matic, Charlie and David are on Scale. And from the perspective of the protocol itself, there's actually no difference at all. It's exactly the same thing. The protocol basically just says, okay, I have a connection to the chain. I'm going to try to make RPC calls at some point in the future. I'm going to make a commitment that can be called to this chain. But as long as you're generating commitments that can be resolved on the chain for any specific channel, it doesn't matter where those channels are. And you're able to transfer from Alice to David here in exactly the same way that you were able to transfer before, where everybody was on the same chain. And it's actually pretty interesting because from the perspective of each different party within the chain, from the perspective of each channel, you literally cannot even tell that these transfers are going across chains in the first place. So we started exploring this concept a little while back. I don't know if everybody remembers, but there was Reddit did this like scalability challenge for the Ethereum space where they pitted all of the Ethereum layer 2s against each other. It was a really, really interesting thing because there was a bunch of layer 2 systems and also the layer 1 chains that came out of the woodwork that nobody had really seen. The requirements that Reddit had posted were pretty intensive, and so like everyone had to kind of either build a custom system or show like the best of what they could do in order to be able to show that this was working. And there was a very, very high bar that was set as a result of like everybody doing this. I think when we looked at that challenge, when we looked at the things that other projects were building, we kind of realized, okay, the Reddit's core requirements are associated with basically having a Turing complete chain-like environment, like running Ethereum but faster, right? They wanted to mint assets, transfer them, and then burn them. That's like general, like you can do that within a channel, but like generally speaking, from Reddit's perspective, really what they wanted was everybody to be able to get access to points, see how many points another person has. Everyone comes to consensus on these assets that are minted, and then eventually comes to consensus on them when they're burned. So rather than building like our own custom system, we thought to ourselves, okay, well, maybe this is an opportunity to explore other use cases for channels, which actually fit into this layer 2 pattern more concretely, and also fit into like multiple chains, like a larger multi-chain ecosystem more concretely. So we built Spacefold. This is actually a GIF. I guess it didn't translate to PDF very well. I didn't think about that. But Spacefold was like a really, really simple UI that was built on top of our existing old Connext v2 code. We kind of hacked it together, and the idea was allow users to instantly transfer between Ethereum testnets and like 5 different testnets of different like upcoming Ethereum layer 2 solutions. So we supported XDAI, Matic. Actually, we supported the mainnet XDAI chain, Matic, Arbitrum, Optimism, and Scale. And then we had kind of done a little bit of a write-up about what it would take to support like Turing complete ZK rollups as well. The idea here was we wanted to explore how users interact with like being able to move funds across chains really quickly, and see if this was actually something that was even interesting in the first place. And under the hood, like the idea was it was very similar to what we were talking about earlier, where it's like you have 2 different channels, or maybe multiple different channels. There's an intermediary Connext node that kind of like sits and provides liquidity on 2 different chains. And you have Alice basically deposit into a multisig, send an off-chain update to Bob, saying, hey, like I want to, in this case, Alice and Bob are the same person because you're just swapping with yourself. But send an off-chain update to yourself saying that, hey, I want to pay myself on another chain, and then the Connext node would like provide liquidity on the second chain and exit. Fairly simple construction. Of course, because we were doing it with so many chains, there was actually like a lot more going on. We had a bunch of, basically we're spinning up like 6 channels. Actually, it was more. It was like 8 channels every single time you open the web page, which was not very efficient. And like I said, this was a very, very hacky demo. And the idea was just like allow users to move from Rinkeby to Scale or Matic or DexDai, whatever, instantaneously as part of this. When we put this out, we, to be honest, we didn't really know what we were expecting. We kind of just wanted to explore the use case and play around with it. We were more interested, we were actually like much more heavily focused on our other target market, which was like peer-to-peer micropayments. But this blew up. Like a lot of people, we kind of realized that this was actually a very, very big problem that a lot of people have been thinking about, but nobody really had been talking about yet, which is like, how do you actually adopt layer 2, Ethereum layer 2 in the first place? How do you even adopt other chains in general and move all of this? Like because I mean, most of the liquidity right now is on Ethereum. How do you actually build new ecosystems, new liquidity pools on other chains unless you have an easy way to get into and out of those chains in the first place? This turned out to be like a huge and pressing problem for a lot of DeFi protocols who said, hey, like, we might, be able to eventually transition to Optimism or Arbitrum or some other chain, but what does it look like for our users when we do that? How do we actually get them to get into this and out of this ecosystem? Because one of the biggest and most powerful things about crypto is that once you have this like steep onboarding curve where you need to like, for Ethereum at least, you need to down, and I recognize it's a very Ethereum-centric talk, but for Ethereum, at least you need to download MetaMask and like get onboarded with ETH and et cetera, et cetera, et cetera. And like, but once you do that, everything is actually pretty insanely seamless. So how do you take that user experience where like you just have a MetaMask account and you're just taking that everywhere with you and turn it into something that works when users are across multiple different chains as well? That was kind of what we learned as a result of Spacefold. And we started immediately thinking about, okay, how can we turn this into a full network? How can we actually solve this core problem for everybody using state channels as part of this broader proliferation of like a multi-chain world, like regardless of, like layer 2 chains, shards, or anything like that. So we built Vector. Vector is a full cross-chain and layer 2 routing network. Basically, the idea is allowing users to route value between different layer 2 ecosystems, different layer 2 chains, and also other layer 1 chains, basically anything that's Turing complete. And the core ethos that went into this was that we wanted to understand, okay, in the same way that that TCP/IP is a shared communication layer that is used to connect heterogeneous networks and the internet, we can have Vector be this shared communication layer that connects different chains within this larger ecosystem. And there's something incredibly powerful here because as a developer, and it's really the developers that benefit the most from this kind of technology. As a developer, though of course this bubbles up to like in user experience to the end user as well. But as a developer, the process of needing to like get different assets and figure out how you actually interact with different chains when you're trying to build an application that runs on like both, leverages both Filecoin and IPFS and Ethereum and like the Graph and Matic and a bunch of other things actually explodes in complexity. And this is something that like we've seen both ourselves as a result of like working with projects that are doing that, and also have kind of seen from the ecosystem. The core idea behind Vector is very, very similar to the internet itself. We have a network of routers. Those routers provide liquidity and forward data between chains. Routers are effectively like service providers, very, very similar to routers on the internet. They have some limited context into what they're actually forwarding, but it's actually not very much there. For the most part, they're like blindly forwarding data. And the ideal case is that eventually they know very little about what they're doing beyond just a basic check to see if they have the liquidity to forward transfers in the first place. And what's even more powerful about this is that rather than just using something like a POS bridge or something like an on-chain atomic swap, routers aggregate liquidity and network effects from the rest of the ecosystem as well. So like if I'm running a router that supports Ethereum and Matic, and then Bob comes online and runs a router that is supporting Ethereum and XDAI, that means now the entire network supports Matic, Ethereum, and XDAI. So a user coming into this network now has access to all three of those chains. So this aggregates liquidity and network effects really, really quickly. It's extremely powerful because you do like one single integration, and now every single person in the network now supports that chain. The overall vision that's been kind of driving this has been, we don't want users to ever know that they're interacting with multiple chains, because the bottom line is users just don't care, right? Like high fidelity users in the ecosystem right now might say, okay, well, I want to check out ZK Sync, or I want to check out Loopring, or I want to check out, like Polkadot, or I want to check out so-and-so. But the reality is that even those high fidelity users, in most cases, don't really understand the underlying technology. And even if they do, like they're really just picking one over the other because of like some slick branding or marketing effort. And more importantly, I think in the long term, as we scale out to like the larger early majority user base, it's not really going to make sense to any new user who is joining the ecosystem that they have funds that are sitting on Near, for instance, and so they have funds on Near and Solana, and they want to interact with a contract that's running on Arbitrum or Optimism, and like the concept of needing to move funds, to bridge funds from Near to Ethereum and then from Ethereum to Optimism is just absurd to them, right? It's never going to make sense. Ideally, what we want is this situation where you have the exact same user flow that you have currently. You have funds in a wallet. The user just sees an aggregated balance. They don't really need to know that these assets may or may not even be on the same chain as each other. And then they're able to call contracts or interact with technology running on different chains, applications running on different chains, without where like all of the swapping and all of the routing to go to a different chain happens in the background. And this is something that we're working on actively with wallet providers right now to come up with a good user experience where ideally what it looks like is basically the exact same as what you're doing today, where you just sign a MetaMask transaction, and instead of just saying the contract address that transaction is going to, it also gives you a chain ID. That's it. That's the difference. What's next? So I actually didn't have time to put together more slides for this, so I'm just going to talk through it, and then also happy to jump into more questions about it afterwards as well. I think we just went live on testnet with Vector a couple of weeks ago. I think we're now we've already started the process of integrating with a couple of chains. There's two chains or a bunch of chains. There's two layer 2 ecosystems that are fully onboarded, and we'll be announcing them soon. And then there's more coming kind of in the pipeline as more testnets start coming up. We have started an audit already, courtesy of ChainSafe, actually. And we expect that to be done, and expect like most of like the audit work to be completed before the end of the year. And the target is to kind of hit the ground running with this with a couple of live applications in January. From there, a big part of what we want to do initially is just bootstrap the network and get some of this, like the early network effects, and also get this up and running, because we recognize that this is an extremely pressing problem for anybody that's using Ethereum layer 2 right now. We've kind of elected to basically have like a minimum viable network where we run with like 5 hard-coded routers first, and we're still looking for folks to do this. Basically, these routers would be like slightly larger liquidity providers that are institutional, have like a little bit more experience keeping nodes online, and initially these will be like hard-coded. So we'll actually have like their addresses, their routing information, what chains they support, how much liquidity they have, et cetera, like uptime, things like that, listed in our documentation until we get the network going. So that's the initial stage, is this like small five node network, which tries to serve as many chains as possible, and then from there, like get this initial adoption, prove out the use case with dApps, show what the user flow actually looks like, and kind of solidify that with the help of like dApps and wallets, and then scale up the number of routers. We have some good ideas on how to do this. If anybody is interested, like there's some really interesting stuff that's come out of Lightning lately, called Lightning Pool, Basically, the idea is rather than having, right now you have like routers manually open channels to users and provide liquidity to them. In Lightning Pool, you actually have a market-based mechanism where like users just put up asks for channels and then routers bid on them. And because of that, now you have this like more decentralized ecosystem where routers don't need to develop expertise or like one-to-one relationships with users. They can actually just like blindly turn this thing on, put some liquidity in it, and it'll just work as long as it's connected to the market. And then secondly, you have a little bit more predictability for the routers, because as a router, one of the hardest things to understand is like, okay, I'm gonna lock up my liquidity here. Is it actually going to be routed over? And in this case, you're kind of guaranteed that it is, which is pretty nice. So that's the direction that we're headed. And as soon as we've implemented our own version of the same kind of concept, we expect to scale up the number of routers really massively, because at that point, running a router is pretty much just running an Avado node or whatever, just throwing it up on an AWS server or anything like that. Really, you could run it on like a Raspberry Pi if you wanted to, and then just plugging in some liquidity. Yeah, so that's kind of our roadmap from here on out. Is we going live in January. We'll have material use cases live with some like DeFi projects where you'll be able to see this working on different chains, and we're really excited to see the kind of feedback that people have as a result of this. If you want to try it out yourself, setting up a test router is pretty easy. It's literally 3 lines of code. You just clone the repo and then make start, and that should set up like a local ecosystem where you can test test like your hardware requirements, and then 2, also do test transfers between 2 local Ganache chains. And then we can also help you work through setting things up like more in more of a prod context if you reach out directly, and we have some docs available. This documentation link is actually out of date. We have new docs that will be moved here soon. But for now, I would say just join our Discord, and then like we can help you out if that's something that you want to get going with. Cool. I don't know how I'm doing on time, but I tried to leave some time at the end for questions as well, which seems like we're doing.
Yeah, well, thank you so much for that talk, Arjun. That was really amazing, and I'm just so excited to see what comes from all of this technology. We're just so proud to be working towards this vision, and really realizing, as you said, a lot of these conversations that you've been having, that people are really just coming to the realization of how important they are to maintain composability across so many of these new upcoming protocols. So beyond all of these exciting projects, to have that glued together is vitally important. So we do have a bunch of questions for you in the Q&A section. So let's start with the first. Aren't capital requirements for this extremely high, as routers must maintain liquidity pools on each chain?
The capital requirements are the exact same as if you did like on-chain atomic swaps, or if you were running like a custodial exchange, or if you were running basically like any sort of system where you're providing liquidity. So it's not too bad. And like the capital requirements for channels typically are high, and we consider them high because there's actually like a broader thought process here, which is like channels in the past were generally thought of as like a solution to payments specifically, and like micropayments more generally, just because like the capital requirements. And like in general, the trade, like what you're trying to do there is compete with like on-chain gas costs, right? So you're basically saying, I'm going to lock up so and so amount of liquidity, and like I'm going to try to route as many transfers as I can using that liquidity, ideally billions, because then that way you don't have to incur on-chain gas costs, which actually drive most of the cost basis for a system like this. However, in this case, you're not actually competing with on-chain gas costs. You're competing with like the possibility of being able to move value between chains in the first place, and that's actually something that's like much more valuable intrinsically. So you can charge a much higher spread on it, and also like people are generally more willing to provide liquidity for something like that than for just a simple transfer in the first place. In general, I mean, I think basically the options are like if you do this. You get instant exits from these systems, and that instant exit from the system will always be cheaper than trying to borrow liquidity against like a 30-day exit or like a 1-week exit, because the instant exit is doesn't like the capital lockup of the instant exit is much lower than the 1 week lockup that you would incur from like trying to exit optimism.
Awesome. Yeah, I mean, also what you've described with the pools, for those who aren't familiar, also kind of help with this problem as well by providing more access to what is that liquidity as well. So the next question we got for you is, what disadvantages or trade-offs are present in a P2P chain / P2P relationships in comparison to a normal chain ecosystem?
Yeah. So I don't know if it's so much about advantages and trade-offs as it is about just like a completely different style of thinking. It's a completely different style of ecosystem in the first place. So like for instance, right? There's like a lot of things that like this is a way that you can think about the trade-off space for like layer 2 scalability in general, right? This is a big part of the reason why like when you think of layer 2 scalability for Ethereum, and like most people when they think of that think of like, okay, let me do Ethereum but just faster. And channels doesn't really fit into that. And the reason for that is that like because it's not a consensus system, you don't have this ecosystem where everybody has access to the same shared global state. You can't run something like Uniswap on that because in Uniswap, like it's a peer-to-contract system. You have this on-chain shared global contract state that everybody is interacting with and everybody needs to know about. You can't ever do that in a channel because in a channel, the state is shared only with your direct peer. Now, that's one of the reasons why it's actually much more effective for something like this than for trying to do just abstract scalability of Ethereum itself. Is that like in this case, we're only specifically talking about transfers of value or contract calls across chains in the first place. And in that limited use case, you don't necessarily need everybody to have access to your state data. I think I would say like the biggest trade-off is like figuring out how. So one thing that we're actively in the process of trying to figure out how to do is how to outsource liquidity for routers. So like right now, there's a tight coupling between like liquidity providers and router operators. You have to do both at the same time because a router is effectively like is effectively a peer within the network, right? So they need to be like, in order to be able to be sure that their own liquidity is secure, they need to be like self-incentivized. They need to be signing for themselves to be able to ensure that transfers are propagated across the network properly. Ideally, what you want is to decouple these things because the overlap of people that are capable of running nodes and the overlap of people that have a lot of money is actually surprisingly low. Like, unfortunately, there aren't a lot of like really like there are more now than there were before, but unfortunately, there aren't a lot of extremely rich people that are just like running nodes at home all the time. So because of that, like ideally, we want to allow for some sort of basically very similar to like existing staking network, some sort of delegated staking mechanism where users can stake 2 routers and then earn a portion of the fees that the routers collect. That's something that we're working on. It's still like an area of very active research and hasn't quite been figured out yet.
Awesome. Well, thank you so much. And yeah, really excited to follow up for anyone who does kind of want to see more about it. All of the Connext information is just down here on the bottom screen. I'm sure they're always looking for people to kind of talk to on their Discord as well. So thank you again, Arjun. And again, I just want to say how excited we are to be, a part of this journey, even if it is in a minor way. And we're just really excited to see how it all develops and where we go from here. So thank you so much for stopping by today. And I'm excited to have you here hopefully next year at CSCON 1 and to see how that year has affected Vector. So yeah, looking forward to talking soon.
Yeah, cool. Thank you so much, Aiden. Thanks for having me.
Of course, it's our pleasure. Talk soon. Bye-bye.